Welcome to today's lesson on Pyramids of Biomass. In our lesson today, we will begin by understanding what pyramids of biomass are. We will then focus on learning how to construct pyramids of biomass, moving towards using data to create accurate representations. By the end of this lesson, you will be equipped with the tools to analyze and interpret biomass at different trophic levels in an ecosystem. So far, you have had a lesson on trophic levels, where we discussed the hierarchical stages in food chains and food webs, starting from producers and moving up to various levels of consumers. This fundamental understanding is crucial as it provides the baseline for us to visualize the distribution of biomass within these trophic levels. Understanding how to construct and interpret pyramids of biomass not only enhances our ecological knowledge, but also allows us to grasp the efficiency of energy transfer in ecosystems. This concept is essential for analysing the health and sustainability of ecosystems and for making informed decisions in conservation biology. Let's get started. To begin, let's briefly review what a pyramid of biomass represents. Pyramids of biomass illustrate the relative mass of organisms at each trophic level in a food chain. As you move up each level, both energy and biomass decrease, typically resulting in fewer organisms at higher levels. For example, 100 dandelions might feed 10 rabbits, which in turn feed 1 fox. However, it is important to note that organism number isn't always the most accurate representation of energy transfer across trophic levels, as it doesn't always decrease as you move up each level. For example, 500 fleas can feed on a single fox. Therefore, biomass is a more accurate measure than organism count. Biomass refers to the mass of living tissues or recently dead tissues that haven't decomposed. It's important to note that it's the dry mass, which means it excludes water content. This is because water is not an energy source, and its content can vary widely between organisms, making it an unreliable measure. As we ascend the trophic levels, biomass decreases. This phenomenon is due to the loss of energy at each trophic level, primarily through metabolic processes like respiration, movement, and heat production. Consequently, the total biomass of producers, like plants, is much greater than the total biomass of the primary consumers that feed on it, like herbivores, which in turn is greater than the total biomass of secondary consumers, like carnivores, that feed on it, and so forth. When constructing a pyramid of biomass, each bar on the pyramid represents the total biomass at a trophic level, and it shows the mass of all the organisms combined at that level. In terms of the structure, each bar should be drawn to scale based on actual biomass data. These pyramids are always pyramid-shaped because biomass decreases at higher trophic levels. The bottom bar represents producers, trophic level 1, followed by primary consumers, secondary consumers, and so on. Each bar should be labelled according to its trophic level and organism type. For example, a typical pyramid of biomass might look like this. The bottom bar is producers, like clover, with the greatest biomass. The next bar is primary consumers, like snails with less biomass. Then we have secondary consumers, like thrushes with finally at the top. Tertiary consumers, like sparrowhawks with the least biomass. Let's break down this example. The bottom bar, producers like clover, has the greatest biomass. These organisms capture sunlight and convert it into chemical energy through photosynthesis, forming the base of the food chain. The next bar, primary consumers like snails, feeds on the producers. The biomass here is lower because energy is lost through basic metabolic processes. The next bar, secondary consumers like thrushes, preys on the primary consumers. Even more energy is lost as we move up. The top bar, tertiary consumers like sparrowhawks, has the least biomass. At each step up, there's a significant reduction in biomass due to the inefficiencies in energy transfer. Usually around 90% of energy is lost at each level. Let's work through some questions to consolidate our knowledge on constructing accurate pyramids of biomass from appropriate data. Question 1. Construct a pyramid of biomass using the following data. The mass of the grass is 500 grams per square meter. The grasshoppers have a mass of 50 grams per square meter, and the snakes have a mass of 5 grams per square meter. Firstly, identify the data for each trophic level. As we have just stated, the mass of the grass is 500 grams per square meter. The grasshoppers have a mass of 50 grams per square meter, and the snakes have a mass of 5 grams per square meter. If we look at the scale factor, the biomass per meter squared is 10 times greater at each trophic level, 5 to 50 to 500, so each bar should be 10 times as big as the one above it. When constructing the pyramid, place the producers at the bottom, as they constitute the first trophic level with the largest biomass. The width of the bar can be any length, as long as the bar above it is 10 times smaller. We can make it 10 centimeters. Label this bar so that it has the biomass per meters squared, 500, and the organism at this trophic level, grass. Above the producers, place the primary consumers. This bar should be 10 times smaller than the bar below it, so in our case, it's 1 centimeter long. Label the bar with the biomass and the organisms. Grasshoppers, 50 grams per meter squared. Finally, place the secondary consumers at the top with the smallest biomass. The bar should be 10 times smaller than the bar below it, so should be 1 millimeter wide. We will represent this as a line. Draw an arrow to this bar and label it with the biomass and organism, 1 millimeter and snakes. The resulting pyramid should visually taper off as it ascends, reflecting the decreasing biomass at each higher trophic level. Check your final pyramid diagram to ensure each level's width accurately represents the provided biomass data. In today's lesson, we learnt how to construct accurate pyramids of biomass from relevant data, an essential concept in the study of trophic levels within an ecosystem. We started by defining a pyramid of biomass and distinguishing it from pyramids of numbers and energy. A pyramid of biomass represents the total mass of living material at each trophic level in an ecosystem, typically showing a decrease in biomass as one moves up from producers to apex predators. Biomass is the mass of living tissues or recently dead tissues that haven't decomposed, excluding water. We discussed the importance of these pyramids in understanding energy flow and the efficiency of energy transfer between trophic levels. Producers, usually plants, form the base of the pyramid, providing energy and biomass to herbivores, which in turn support carnivores and eventually top predators. Biomass decreases as you go up trophic levels because energy is lost through metabolic processes such as respiration, movement, and heat production. You were shown step-by-step methods for constructing these pyramids from data. The width of each bar in the pyramid should be relative to width of the bar below, depending on how much biomass has been transferred to that level. With this foundation, you should now be equipped to construct accurate pyramids of biomass and appreciate their significance in the study of ecology and energy flow in ecosystems.
Watch the rest of the GCSE biology course at Sophos Education.